What's going on, everyone? In this video I want to talk about attacking JSON Web Tokens. So if you don't know what JSON Web Tokens are, they're typically used for authentication or authorization purposes in things like web applications, mobile apps, APIs, things like that. So what do JSON Web Tokens look like if you don't know? Here's a quick overview. They're made up of three parts: a header, a payload, and a signature, which is all base 64 and split up using full stops. So when you decode that base 64, this is what a JSON Web Token looks like. Your header here has an algorithm typically. Your payload has any data that the developers want to put in there, and the signature is the signing entity of the JSON Web Token, which essentially makes sure that developers can create JSON Web Tokens, but attackers can't just edit JSON Web Tokens or create their own. So this is usually signed using a key or a certificate, and that's denominated using this algorithm tag. So how do you attack JSON Web Tokens? Well, there's a few ways, which I explain in my blog and I'm going to explain now. The first ways aren't really attacks, they're just things to look out for, so sensitive data and not expiring tokens. So if you see in this payload data, you can see that developers might have put some sensitive data like a user's password. It might be a password hash that you can crack, something sensitive like that. So if you can gain access to another user's JSON Web Token, whether you social engineer that or take it from a web proxy or something like that, and then you decode it, if you see this sensitive data, you might be able to log in as that user. So best practice for developers is to get rid of any sensitive data that might be in JSON Web Tokens because someone might see it. The next thing is there's no expiry within the payload. You can see that there's a name, there's an issue time, there's no expiry. So this might mean that the JSON Web Token is valid indefinitely. So if you can gain access to a user's token, you might be able to use that forever. So what you need is not exploit known vulnerabilities. What you need is an EXP for expiry and then just an expiry time, just make it valid. That's what you need. Anyway, let's get into some actual attacks. So there's a website called JSON Web Token Lab HerokuApp.com. It's in the description, check it out. And this is basically a kind of capture the flag for JSON Web Tokens. It doesn't go through every single attack possible, but it goes through a lot of them and you get the kind of general idea. So first thing to do is go to users, go all the way to the bottom and create yourself a new user using this new user button here. I've already done it, so I'm not going to do it again. Then go to challenges. Here's your available labs. The first challenge we're going to do is the None algorithm. So what I recommend you need to do these labs is a cookie editor. So I'm using cookie editor for Firefox. There's the same thing for Chrome as well if you're doing it in that. And the first thing we need to do is register a user and gain access to the admin user. So if we log in as my user, you can now see that the current user is Turv, which is what I've just logged in as. The purpose of this is to gain access to the admin user. So if I just take my token here, which is in the challenge cookie, this might be a cookie in a web app, it could be a bearer token in HTTP headers, it could be in a few places, but as I say, it's in a cookie this time. So if I take that cookie, put it into the website we were just looking at, you can see this base 64 decoded data. It's using the RS-256 algorithm, which is a certificate based, which is why it's asking for a certificate. And you can see the payload data is name equals Turv, which is me, and that's why I'm signed in as user Turv. So what we need to do is change this name to admin rather than Turv. And we can't just simply type in admin here, take this cookie, take this token and put it into the cookie and it'll work, because the signature isn't correct. I mean, I don't have the certificate to sign this, the developers do. So we need an attack that will allow us to gain access to the admin user. And the way we can do this is, or at least in this example, is use the None algorithm. So essentially what happens here is in the algorithm, None is entered, admin is entered here, and then we remove the signature from that payload. So it's not really that easy to do it in this website. So there's a great tool called JSON Web Token Tool. And you can see here under the X tab, under the X flag, all of the different attacks that can be done with it. So I've already got this set up. So Python 3 JSON Web Token.py, just paste in our JSON Web Token there. And then the I flag means that we want to change this JSON Web Token. The PC flag is name, which is that name payload data here. And then we want to change the turv to admin. So we go PV flag admin. So that will change that turv to admin. The X flag denominates the attack, which A is null from the documentation. A equals null. None attack. So if I just go ahead and enter that, you'll see various tokens being given to you. And that's because the algorithm can be changed to none, it can be changed to none with a capital, and a few others, so camel case example. So just take one of these. You'll see that there's only two base64 encoded strings here. One's there, then a full stop, and one's there, and then another full stop. So the signature is actually omitted here, and that's what you need to do for a none algorithm, because obviously none means no algorithm, so there's no signing, if that makes sense. So if you then go copy that and then put that into your token here, we'll have gone from user turv to, when we refresh, user admin. So that's the none attack. The none attack means that signatures aren't being used. It's the none algorithm. So if we then move on to the next challenge, which I'm not going to do expose key this time, I'm going to do signature not checked, because it's kind of the next logical step after a none attack. If I go ahead and just remove my cookies here, because it's a similar attack to the last one. Log into my user again. My user is turv. If I take that cookie, pop it back into the JSON Web Token website so we can look at it, it's as similar to the last one. So all this attack is going to do when we use the JSON Web Token tool, which is this one. If I pop the JSON Web Token in again, this time everything's exactly the same, apart from the exploit is now N instead of A. And all this does is it removes the signature, but it doesn't change the none algorithm, the algorithm to none. It keeps it as the RS256, as you can see here, but it's changed the name to admin and it's omitted the signature. So if we put that into here again and refresh, we're admin. So the two exploits I've shown you there is the algorithm being none, meaning it's not checking a signature, and the second one is it is using a signature, but it's not actually verifying that that signature is valid. So those are some very easy attacks. The next one is an exposed key, or it's sometimes called a key confusion attack. So if you can gain access to the public key being used, you might be able to change the algorithm from a certificate-based algorithm to a key-based algorithm and use the public key as the key. And I'll show you what I mean by that. So if we log in as my user again, I'm logged in as turv and it's using the algorithm RS256. So if I take that cookie and just verify that, yep, it's using the RS256 algorithm with the name turv. Great. So now this signature is being checked. So I can't just change it and do what I did last time. What I have to do now is try and trick it. So rather than using the RS256 algorithm, which is a certificate, we're going to change that to a HS256, which uses a key. And for that key, we're going to use the public certificate of the RS256 key signing algorithm. It's a bit confusing, but bear with me here. So using this public key here, which we've got from the website, you can also use OpenSSL to connect to the website and gain the public key back that way, which I'm not going to show you here. It gets a bit complex, but if you take this public key, pop it into a Word, a text file, which I've already done, and I've called it public key. You can use JSON Web Token tool. I'm just going to go back and grab that JSON Web Token, pop it into here, use the I to tamper with the JSON Web Token. We're doing the same thing with the name and admin. The exploit is K for the key confusion attack, and the key we're using is public key, which is that key here. So again, just to reiterate, what I'm doing here is changing the algorithm from RS256, which is a certificate, to HS256, which is a key-based signing algorithm, and we're using the public key as the key. So we're not using the private key at all here. We're tricking the algorithms to use the public key rather than the private key. If we enter that, take the JSON Web Token that it's provided us and pop that into here, save it, and we're now an admin using key confusion. So again, what we've done there is change the algorithm from RS256 to HS256, which just takes a single pass key, and we've used the public key as that pass key to confuse the JSON Web Token implementation to think it's taking in the private key when it's actually just using the public key. Bit confusing, but that is how it works. So the next thing is weak signature, and what they want you to do here is crack the key that signs the certificate, essentially. The key that signs the JSON Web Token. They've provided a word list here. Obviously, a real website wouldn't do that. You need your own word list, but you can take that word list and use it in a minute. So let's just log in again. I'm logged in as Turv. We'll take that key, JSON Web Token. We'll pop that into the JSON Web Token so we can see it. It's using the HS256, name's Turv. Okay, great. So let's then put that into our JSON Web Token tool again. This time we're going to use the C flag for cracking, the D flag and the word list that I just showed you. And what it's going to do is it's going to try and crack that JSON Web Token to try and basically find the signing key. And as you can see, I love you out of that word list was the correct key. So what we now need to do is sign a JSON Web Token so we can become an admin using the I love you key, which I should have back here somewhere. So using the same JSON Web Token and then the I, PC flag and PV flags that we've used previously, we're now going to use the S flag. It's actually HS256, which is the algorithm being used, and the password is I love you. Take the output JSON Web Token there, which has been signed using I love you, and we've obviously changed the data. If we then go ahead and put that into the challenge cookie, we're now an admin. So we've just brute forced the key, and that's why I said earlier that I prefer certificate-based signing than this simple key-based signing, because you'd firstly have to get the certificate before you do any brute forcing. Much more secure implementation, providing certificates aren't publicly available for some reason. Okay, so the last one here is vulnerable kid. So I'll show you this first. Logging in, you'll see that my current user is Turv. If I go ahead and show you the JSON Web Token here, you'll see that we've got a kid value in the header and the name is Turv again. So what the kid value does is it specifies a file within the web backend structure, the web root structure, to verify this key against. So when you try and use this JSON Web Token, it will look at the RSA private key and make sure that it's a valid signature using this key. So this kid value can be vulnerable to SQL injection, it can be vulnerable to signing against another file if you can see it in the web root. So for example, they give you this random page here, and this is the web root file that they want you to exploit this with. So if you go ahead and take that, and we'll use JSON Web Token tool once more, you can do JSON Web Token tool. Sorry, let me just take the challenge token again. Pop your JSON Web Token in there. We're going to use the I, PC and PV flags like we have been using, but this time we're going to be doing the HC flag, which is changing the header value kid, which we've already seen is this RSA private value. So it's going to change the kid value to app views authentication random html.erb, which was that random page that we've got here. So what's going to happen here is the token is going to change the kid value to this path, and it's going to validate the signature against whatever's in this file, which we can see is actually find me in that. It's going to validate against this string here. So what we've done is we've changed the kid file, we're signing it with HS256 again, which is because that's what it's signed with, and the password is going to be find me in app views authentication random blah blah blah, because that is what is inside this kid file. So we can now take this go to challenge, pop the JSON Web Token in there, save it, and we are now an admin. And that's how you exploit the KID vulnerability. So just to reiterate, that is changing the KID value to any file within the web root structure that you can access and see the contents of. So this random page would be that file. You can access it, you can see this is the contents, and you can see this is what the file actually is. So we've changed that KID value to just this, because that's what this random file relates to in the web root, and then the contents of this is the key. So you can do that with any file in the web root, and that's how you exploit this issue. And as I said, this can sometimes also be SQL injectable, so that's another path to look down. So that's all of the challenges. As I say, there are more JSON Web Token attacks. These are the main ones. But yeah, that's the JSON Web Token attacking video. Check out my blog because I've got more stuff on there than what I've shown in here. And I hope you've learned something. Thanks for watching.